Hi everyone, welcome to this week's webinar with me, Terry Genby. We are going to have a little look at lateral movement and how we can use the Simulate platform to identify what lateral movement actually looks like for our organisation, because there's many different parts to it. It could be at the endpoint, it could be about our network segmentation, our firewalling, could be of credentials, but it's really key that we identify what that actually looks like. It's not a straightforward thing for any organisation of any shape or size to do. So what I'm going to do is just share the screen and show the actual main Simulate dashboard. And then we're going to talk a little bit about how we can identify this lateral movement capability. How could an attacker potentially start to spread and replicate for our environment? What are the resources, the things that are in place that allow them to be successful? And how we can start to combat that and actually sort of detect that behavior in the future. So let me do the difficult thing there and just share my screen. And let's bring the dashboard into life. Now, ever so quickly, just a little bit of orientation around the dashboard here. What are we actually showing? So at Simulate, we are an XSPM vendor, an extended security posture management platform. And we are there to identify how effective your security controls are by validating them and testing them in the same way that an attacker would. All of which is aligned to the kill chain, and all of which are denoted by these circles here that we're seeing on the screen. Each one of these has its own score, and it's very, very simple. It's like gamifying security. The higher the score, the higher the risk. So what we really want are scores as low as possible, because then we're assured we're always getting that level of protection we're expecting. And as I said for today, we're going to be focusing on this area here, around lateral movement capabilities. How something could spread and propagate on our environment, and what that actually looks like. How would it be successful? So, lateral movement. The first area that we're going to dig into today is our ability to prevent that type of behavior. What would happen if an attacker managed to compromise our perimeter? We're going to be able to identify, first of all, using the platform, how something could get through that perimeter. But if it arrives at this endpoint, that's going to become our battleground. Our first line of defense is probably going to be something like our EDR tool. Now, we really want to understand how effective would that EDR tool be, and actually recognizing that worm behavior, that lateral movement type of attack taking place. How would it prevent it? But also a couple of other benefits off the back of that as well is, if we've got something like a SIEM tool in place, we can start to validate, okay, what type of behaviors are we capable of detecting and alerting upon? Are our rules, our detection rules and alerts in place doing their job correctly? So we're going to have a look at endpoint security to start. So with endpoint security, the first thing we're going to want to do is get that yes or no answer. Would my endpoint security product of choice actually recognize that behavior and prevent it? And the way that we're going to do that is we're going to talk about scenarios. We're going to talk about, in particular, Simulate scenarios. Now, these scenarios are all out-of-the-box attacks that have been built from the ground up by Simulate to reflect the actions and capabilities of their genuine malicious counterparts, but without any threat of causing any harm or any operational impact. Now, these scenarios, we can see here, there's 86 of them that are available for us to test with. If we maximize any of them, we are going to be able to see precisely what they're going to be doing. And we can see at this point in time, and for those that are familiar with it, it's aligning to the MITRE attack framework. So by running this testing methodology, again, we can start to evidence our detection and prevention capabilities of using frameworks like MITRE. Now, what we're going to be doing with these attacks is we're going to be downloading them to a device in your environment. So we are going to be looking to install a single Simulate agent onto a device that is representative of the many. It certainly isn't an agent on every device. That's too big, too complex, and it's not really a real-world testing approach. An attacker is highly unlikely to ask to install agents on every single device in your environment and then just prove that those vendor agents can talk to each other. That's not genuine lateral movement. Our agent's job is to act like the target of the attack or the initiator of the attack. It's going to create dummy data that we're allowed to interact with, things that we're allowed to handle, so we don't touch anything that belongs to you as a customer that could potentially cause harm. It's there to report on our progress, and it's there as well to clear up after ourselves. So at this point in time, we're going to ask for that single device with a gold build or standard image that has the same EDR tool of choice installed, and we're going to install our agent onto it, and that's going to act like our testing device. Ideally, that device to be on the same network segment as our other devices, because that's going to allow us to progress to the next level of testing once we've done talking about this endpoint security part. So with these scenarios, what we're going to be doing is we are going to be running this on the device. We're going to be downloading it. We're going to be executing it without any chance of any harm. At that point in time, this is going to be a system testing systems. There's going to be no bias there. We're not going to be favored towards any vendor in particular, but what we're going to be doing is identifying, right, which one of these tactics and techniques or combination of behaviors are going to be successful, what's going to be recognized to be stopped by our tool, and what's going to be alerted upon. Now to run this test, we're going to choose our template we wish to actually operate with. The platform supports full multi-tenancy, so we can run this in multiple environments and benchline each one independently if we've got different EDR tools or different controls in place. We would choose our target, which is going to be our test device running the agent. And then we've got two considerations. One being our frequency of testing. If we want that continuous assurance piece, we can run on a schedule you're choosing. But for this instance, we would just hit the launch button. It's going to be a one-off ad hoc test, but once that test wraps up, we're going to know how effective our endpoint security tool has been against recognizing, preventing, and telling us about those ransomware, those lateral movement attacks, at the endpoint, those worm behaviors. Now, once that test wraps up, it's going to become about the reporting output. And then we can start to digest, right, how did that attack actually take place? What was the initial execution method, the behaviors used? How can we mitigate and how we can detect that? And how effective our controls were. Now, if we jump into the report, we've got three different ways, or three main ways of consuming that information. There's actually a few more in there as well. We've got via the Simulate interface. We've got exportable reports, which can be tiered depending on what level of information we need for our role. We've got an API that can be used if we wish to consume the data in a different way. And also we've got findings on our own dashboards that we can create via the main UI as well. But here we're going to take a little look at our last endpoint security report. We're going to start to understand, right, how effective was our EDR tool at recognizing and preventing those worm behaviors, those lateral movement types of attacks. And here we can see that actually in this case here, all 70 of the worms that we tested on this device were recognized and were prevented, which is a great place to be. But if any of these were to be successful, then of course we're going to want to investigate those. We're going to want to start to understand, right, how did it actually execute? How far through that attack life cycle did it progress? And what of those behaviors are actually detected and alerted upon? Now, we've got our worms in here. Even in this lab, they were prevented. We can start to understand, right, how far through did any of these actually progress in the first place? If we choose an example in here, let's go for this one in the middle, for example. We can start to learn and we can start to understand how would that worm actually have been successful in the first place? How would that lateral movement attack have actually initiated? So across the top of the screen here, it's showing us each and every stage of that attack. And we can see here that we got through to discovering targets before we tried to replicate ourselves using WMI. And that's the point in which we were prevented. We were actually stopped in our tracks. Now underneath, we've got each of those stages once more with a description about precisely what we have done every single time, because it's best to be open and transparent. We need to learn from what's actually taking place. There's no point hiding that behavior. For each of those stages, we've aligned it where applicable to the MITRE attack framework, and then we can start to learn from it. Now, this attack here, we know, actually got through 8 stages before it was recognized and prevented. But what if we want to tighten up our recognition, our prevention, our detection at a lot earlier on in that cycle? What if we actually wanted to understand, right, how can we prevent the injection of DLLs in the first place? Well, if we hit that more information button, the first thing we're going to get there is a description about the technique. So we can start to learn about it. We've got the alignment to the MITRE attack framework. And then next, we've got the detection information based on registry entries, event IDs, all the things that are relevant to that technique. How to mitigate that type of behavior in the future. Great. So now we can know how to recognize it and how we can start to stop it. We've also got a couple of other considerations here to think about as well. We've not spoken about integrations at this point in time or making use of our existing tool sets, but how can we validate that they're doing what they're meant to be doing? How can we validate those alerts, that detection process? Well, the first thing we can start to look at is the support of the Sigma rule format. Sigma rule is a great thing for a lot of organizations out there to actually start to become acquainted with. It's an open framework used by a lot of cybersecurity vendors that allow you to take a series of events relating to behaviors and then run a generic query against your tool of choice to identify, right, what was actually seen. Do we get the overall picture relating to this case in terms of reflective DLL injection? It could be something like control panel utility. It could be elevating privileges. But whatever happens here, we've got that visibility now. We've got that ability to generate that query and go and look for that type of behavior. This is a great step if we want to train something like a junior SOC analyst, for example. We're going to run the attack. We're going to ask them to manually go and validate what did our tools alert and detect and actually tell us about, and whether we've got any gaps in recognizing any of those behaviors. So in Simulate, our in-house blue team have documented that there's two ways in this case of actually running that reflective DLL injection attack. We've got the events IDs, the key entries, whatever's relevant to that behavior. And in here, we can start to choose our tool of choice that supports that Sigma format. We can generate our query, and then we can copy and paste, in this case into Kibana, and look for it manually. Did it see any information relating to this attack? If it did, great. If it didn't, we've got a couple of areas we need to investigate. Is our EDR tool pushing those events and alerts back into our Kibana instance, for instance, or into our Splunk instance, into whatever tool we're using? If it is, great, but why aren't we seeing any alerts? Maybe we've got an issue with our rule set. What do we need to improve that rule coverage? Well, there's all the information there. And that's a manual step, but it's always good to do those manual exercises. Now, how can we start to automate that and pull through those events and alerts back into the Simulate UI? Well, the platform will support integration directly with our EDR tool and with our SIEM tool. And all of those can be found via the main web interface. At that point in time, we will actually automate sending our attack indicators through to those tools and validating the events and the alerts back into that submenu within our UI. If it can see it and stopping it, and it's telling us it's not very nice, it's great to validate that, and we'll pull through that confirmation. If we're not seeing it though, or we're not stopping it, then you've got that information readily at hand for each of those steps. So at that point in time, we've dipped our toe into the world of lateral movement. We've got a yes or no answer. Would our EDR tool actually prevent something at the endpoint from taking hold? Our next consideration is, if that device were to be compromised, what's the blast radius? What's the impact of that compromised device? How far can something propagate and spread throughout our environment based on our network topology, based on the credentials available on that device? That is where the lateral movement module itself starts to come into play. Now, with lateral movement, we are going to be building a templated test to identify how we want to try and spread and replicate in the environment, how we want to try and obtain those tickets, tokens, or credentials, and more importantly, the scope of the test. What's key to note is when we talk about the lateral movement module, we will generally be moving laterally within your environment. But it is all safe, there's no chance of causing any harm, and we will not be using vulnerabilities to do that. And no matter what any vendor claims, you cannot safely make use of a vulnerability, because if we're talking lateral movement, you do not know what device you're going to end up on. So you do not know what pressure that device is under, what's running on it, and you don't want to run any risk of using a vulnerability which is going to detract from genuine system resources. We don't need to do that with a Simulate platform. Once we've built our template, it's the same workflow again. We choose our environment we want to run the test, we choose our device that's running the agent, and that device now is going to become patient zero. So in effect, we're going to scan the network around that device to identify other devices and other targets in range, based on that spreading method that we've actually told the platform about. We're going to try to obtain tickets, tokens, or credentials. We're going to handle them offline so there's no chance of locking accounts or causing any harm. those credentials we discover will never, ever, ever enter the Simulate platform. They'll be held and handled on that device in your environment. We don't want that information. No vendor should have that information. And then what we're going to attempt to do is to move laterally and replicate into the memory of other target devices. And once we've wrapped up our actions, we're going to be left with just that one single Simulate agent at the end of the test. Now, what that's going to give us is that term, that blast radius. And we're going to get a report which could look a little bit like this. And here in the middle is my one single Simulate agent. And this is showing me that we have managed to propagate and move laterally to all of these other devices. It is genuine lateral movement. This is not just saying Simulate agent A can talk to Simulate agent B. No, this is one single agent that has managed to replicate and run in the memory of all of these other devices. Genuine lateral movement. Blue is a workstation or laptop. Amber is running a web or database service. Red is a domain controller, or we found domain admin credentials, or it's a crown jewel, a critical device or account that we've been told to keep an eye out for. We shouldn't be capable of discovering it, but actually here we can see we found a number of those devices. Now let's talk a little bit about use cases. Why might I want to test lateral movement in this way? Well, this device over here, my starting point, my patient 0, could be in a DMZ environment. That's in an environment that's publicly facing, that's firewalled away from our main corporate network. And I want to understand what would happen if that public-facing environment were to be compromised. Could something spread through the firewalls, through the VPNs, through the firewalling and zoning, whatever's in place, and reach my corporate network? If that were to be the case here, clearly we've got issues. This could be a device that's in a user network where we know we've got people who repeatedly click on phishing emails. We've trained them, but despite our best efforts, they keep clicking on things. Well, now we can start to understand, right, if a device in that environment were to be compromised, again, how far could an attacker spread based on our network topology, the credentials, and the resources available? It might be we're looking at a very expensive privileged access management solution, where we want to understand, first of all, how we got an issue with overprivileged accounts. Whatever the use case, we can start to pick it apart now. Let's choose this device over here. I want to know precisely how something moving laterally managed to spread from this device in this network segment and arrive, in this case, on a domain controller. I choose the device in question, and now it's showing me the route the agent has taken. Now I can start to piece together the bits of the puzzle. I've got that yes or no answer by running the endpoint security test. Would my EDR tool save me? But in the case if it didn't, or if I wanted to know, right, what else exists that I can start to deal with and start to tighten up, I can start to ask the question, should these devices be capable of talking to each other? And actually we can see that they've all been able to communicate using SMB. And again, the platform's going to give me that mitigation information and the text information, so I can go and tighten that up. So my first question here is, should these devices be capable of talking to each other? If they shouldn't, let's tighten up our networking level. Let's tighten up our VPNs, our firewalls, our routing, whatever's in place. My second question, for this replication here, this first hop, whose account is that? Why would that service be using it? And why is it clearly overprivileged? And actually we can see here, we've got an issue with privileged accounts. Now I'm starting to build the picture of what lateral movement actually looks like for me. Would my EDR save, detect, and alert? Would my SIEM alert? Where have I got those gaps at that networking level? And where I've got issues with credentials? If I can deal with the credentials or the networking layer, I can start to break the link in that chain. If I can stop this from replicating onwards. Now, a point I made earlier on, which is very key, is we've not used any vulnerabilities when we've carried out these types of actions, because you can't guarantee the safe use of them. So how can we start to deal with the problem of patching? Quite simply, if there's a vulnerability scanner already running in your environment, we can integrate with it. If we prove that we can replicate to another device, then what we'll do is we'll consume that vulnerability scanner output, and we will actually start to demonstrate to you whether our vulnerabilities in place that relate to lateral movement without us actually having to use the vulnerability and potentially cause harm. Again, we've got some more considerations at that point. Can we patch it? Yes. great. We know there's attacks associated with it. We can patch it, and then we can run the test afterwards to validate, yes, that vulnerability can no longer be leveraged. But what if we can't patch it? What if we've got a legacy environment, or we just can't patch everything in one go? Well, if we can't patch it, we've still evidenced to you other ways in which we can prevent something from moving laterally to one of these devices. If we can't patch it, again, if we can deal with the network layer, tighten up our access control lists, our firewalls, whatever it may be, or we bring the credentials under management and we sort out that actual privilege issue, then again, we can start to break that chain again once more. So it's starting to give us 3 parts of how we can start to do a lateral movement. We've got the endpoint, we've got our networking layer, we've got credentials, and then we've got patching. Now, there's one final area of lateral movement which we can start to go into, and it really starts to go more into that red teaming, that offensive testing sort of arena. Where we start to wrap that up, we bring it into our advanced scenario capability. Now, advanced scenarios has this dashboard here, and it's a heat map. It's about showing us our prevention and our detection coverage of the MITRE attack framework, but also NIST 800. All of which we've mapped through to various attack groups and attack software. So again, if somebody says, okay, can you tell us whether APT38 would be an issue for us, for instance, or any threat actor, we can quickly see, right, what can we detect and what can we prevent? Now in here, the testing approach is still going to be templated, but because we're talking about advanced scenarios, we are giving you the ability to test specific executions, the specific building blocks, the specific components that make up an overall behavior scenario. It allows us to be as granular as we like now. So if we want to talk about lateral movement once more, maybe we want to choose tactics and techniques that are more relevant to a specific operating system, like Mac or Linux. Maybe we want to look at password spraying for Azure. Or maybe we want to run an exercise which typically would be done as part of a red teaming engagement. A great example of that is dumping hashes or dumping passwords off a domain controller and then trying to brute force them. Those types of activities may take place every 6 months. But if we can actually start to run that more frequently, then we're going to be able to keep on top of anybody who might have actually set weak passwords, for example. Well, if we want to know precisely what that test is going to be doing, again, it's just picking on one part of lateral movement, which is actually trying to attempt to identify where we've got those simple passwords and how we can actually start to crack them in the first place. It's going to give us that ability. And here we can see the 3 different executions that make up that test. Maybe we want to start looking at curb roasting on the environment, seeing if we can get those tokens, and again, attempting to actually guess the password using an offensive tool like Jack the Ripper, or John the Ripper, sorry, for example, and see whether there's anything there which is simple again, which can be cracked easily. But it's about being as granular as we like. Once we run that test, it's all going to be about validating the detection and the prevention capabilities once more. Now, to give you an example of the output for running one of those tests, here's some of our tests we've run in this lab previously. And if we choose any example in here, let's pick on something like SolarWinds, for example. There's going to be an element of trying to handle credentials in there. This is validating what our EDR tool and what our SIEM tool are seeing and preventing. But the real information is going to be in the findings. And again, we've got each of the executions that have been tested. We have got whether it's been prevented or whether it's detected. And again, it's like gamifying security. We want as many green ticks as possible. But if we find ourselves in this position where we're getting these red crosses, it wasn't prevented, it wasn't detected, then once more, the platform's going to give us that information. It's going to show us the code that's been run. It's going to show us the mitigation information. And more importantly, it's doing all that reporting output for us. It's showing us the tags, other attack groups, other frameworks, where we can start to map that behavior back into. We can also see we chose to clean up after ourselves. But if we scroll to the top, security control detection, I've got my attack indicators. Whether it's the tool that we've actually executed to try and grab that information or to run that technique, or the overall simulate attack indicator, I can look for those manually as part of that manual exercise and validate what did my tools actually see, what did they stop, and what did they alert upon. I've got my detection information once more, And again, I've got that handy signal rule generated down the bottom. I can choose the different ways of running the DLL injection there. I can choose my different supported technology, generate the query, look for it manually, write the rule, validate the rules in place, and then rerun the test. If I get this into a happy place, into a happy medium, I've got it as green as possible, I've got all those lovely ticks and boxes, I can then start to talk about that assurance program. I can add this test into an assurance queue, run on the schedule of my choosing, and then if anything changes, of course the platform's going to log an alert and tell me what's gone on. And if I'm using one of the many dashboards that I can create, where I've got those reports automatically arriving into my mailbox, I'm going to be able to act on that a lot quicker. So 3 ways there of where we can really start to break down lateral movement. Just to recap, at the endpoint in a non-invasive manner, would a lateral movement attack or worm attack actually be successful in execution? Would it be prevented? Would it be detected? Would my SIEM tool alert on that behavior as well? With lateral movement, how far could an attack actually propagate and spread in my environment based on the resources that are available to discover? Tickets, tokens, credentials, gaps in my networking level. Also, what vulnerabilities exist which could also allow an attack to be used for that lateral movement attack? And then finally, advanced scenarios where we can be as granular as we like based on specific techniques, whether it's relating to legacy on-prem, an operating system, even something within a cloud environment. It's all covered within the platform, and it really comes down to what your specific use case is. So at that point in time, that's going to conclude the demo today. If you've got any questions or any queries based on what you've seen here today, please feel free to contact me directly at terryj@simulate.com or get in contact via simulate.com from the main website. But thank you ever so much for your time today.